Good morning. Welcome back. I would love actually to proceed with the lectures. We will tackle today the topic of methods after taking a look at several constructs to implement conditional algorithms as well as iterative algorithms. The topic of today is how to divide the program in such a way that the program won't be written in one single method, which is actually the main method, in one single part. But what we want actually to do is, once the problem would become bigger, we would love actually to decompose the problem into subproblems. These subproblems will be implemented in terms of methods. Methods are nothing else than functions in math. And last but not least, once we are done with solving the subproblems, we conquer, let's say, these methods to solve actually the original problem in this case. Let me start to give you an idea about the first program that we implemented in the first lecture. It was actually the baby cry program, just to implement the hello world, where at the end of the day we had actually to implement a method. The method is called main. It takes as a parameter an array of strings. We will see later why this argument is needed. And last but not least, the body of the method is having a print line statement, just to print the string hello world. Now, let's go and think about another problem that we want actually to implement. Okay, thus I will go and move actually to Java, okay, to JCreator. And then what I want actually to do is, I want actually to implement now a program that will calculate the factorial of one number. Thus, I have already prepared actually the program to accept input from the user. Thus, I will ask the user to input a number. Please enter a number. And then what I will do is, I will just use the method print next int, just actually to get the integer actually from the user in this case. Thus I will write sc.nextInt in order that the user will receive, in this case, an input, that the program will receive an input from the user in this case. Now, if I want actually to implement an algorithm to compute the x factorial, then we know exactly that x factorial corresponds to the multiplication of 1 times 2 times 3 times 4 till you reach x. In this case, the best loop to be used actually to solve this problem is just actually the counter loop, the for loop. Okay, thus I will start with I equal to 1. And what I will do is I will just go and increment actually the I by 1 till actually my I reaches x plus 1. If the I is still less than or equal to x, meaning I have actually to multiply further. And last but not least, inside the program, I will have a result variable that I will take and multiply actually every time times I. Thus, to do that, I have actually first to initialize the r to be equal to 1. Okay, and last but not least, I will just calculate the factorial of x. Okay, thus in order that everyone actually will see it, I will just add a statement, the factorial of now plus x is, and then I will just actually display the r. Thus, once I will compile, the program hopefully will compile correctly. And once we will start to run the algorithm, I will get actually just a dialogue with the program. The program will ask me to enter a number. Okay, I will enter 5 and I'm expecting to get 120 as a result, and the result is correct. Now, what we want actually to do now is to change actually the program slightly. We want actually that the user will enter two numbers, okay, x and y. And at the end of the day, the x factorial has to be calculated as well as the y factorial in one single run. Okay, to do that, what I will do is actually something ugly. I will take, let's say, the whole part that we implemented actually so far, and then I will replicate it. Okay, now what I will do is I will just change the x by y. Instead of having r, I will have actually r1. I will be changing the x by y. And last but not least, this one is r1. And then what I want to do is I want actually to calculate the factorial of x as well as the factorial of y. And this one actually will be stored into a variable which is called r1. Now, once I will compile and I run actually my algorithm, okay, the algorithm hopefully actually will work, and I will have actually the first dialog. That means I will enter a first number, which is 5. Then I have to get 120 as a result, okay? And the program will require actually to enter another number. In this case, I will enter 6, and what I get as a result is the factorial of 6 is 720. Okay, thus you see that actually in this case we replicated the code twice, okay, in order actually to have also the statement system.out.println, please enter a number every time. What I will do is I will go and replicate it after, let's say, the display of the first result. Okay, that's just actually to see it again. Once I will compile and I will run, what we will be getting here is we'll be getting again a dialog with the program. Okay, first of all, to enter the first number, it's actually 5. You get actually 120. Please enter another number. I will be entering 7. Okay, the result should be 5040, and you get actually a correct result in this case. Okay, the problem is solved. However, I have a small problem that actually the algorithm will become a little bit monolithic, meaning some people actually they will call it spaghetti code. You will be having everything, the whole algorithm will be implemented in one part. Okay, you are replicating actually the code, and last but not least, the more complicated the problem will become, the tougher it will be to read and maintain actually the program in this case. And that's why the topic of today is just actually to think about solving actually the problem of the factorial in a specific actually part in the code. And then once I want actually to call it, I can call it once, I can call it twice, I can call it thrice, but I can call it also 1,000 times. If I don't want actually to call it, I will not call it at all. Okay, that's what we want actually to do today is just actually to write methods inside actually the class, okay? With class, I gave it actually the name methods in order actually to have a self-explanatory, let's say, name in this case. Okay, thus now what we want actually to do is we want actually to implement a method that will calculate the factorial of a number. Okay, thus like in math, you have actually to think about the following. A method is nothing else than, let's say, just a function. Okay, I will just give you an example. A function, the function will be taking actually parameters, and actually you are having the definition of the function itself. Now, the principle is similar, the principle of method is similar to mathematical functions. What we will do is we'll be implementing a function which we call actually a method in Java. In C, we call it actually a function. The function, the method can take actually 0 parameters, it can take 1 parameters, it can but it can also take, let's say, 1,000 parameters. Okay, and this is actually, we call it the signature of the method. And last but not least, we want actually to implement what the method actually should perform. And this is actually the part where we will implement it in the body of the method. Okay, thus, let me go back and try actually to implement a method in this case which calculates the factorial of a number. Thus, I will go and implement a method. The method has a specific signature. First of all, it has actually an access modifier public. Public means even if I am outside this class, I will be able to access it. Static means that actually the method will be expecting parameters actually to be passed to it. Okay, then after actually writing static, we have to think about what kind of data type the method will return. Thus, the method will return a result of type integer, and that's why I will be writing int. And last but not least, I will call the method factorial. Okay, it takes as a parameter x. Now, in Java, we said whenever actually we want to define a variable, first of all, we have to declare it, meaning we have to give it actually its corresponding data type. Thus, what I will do is I will implement a method. The method now is called factorial int x. Okay, it takes as a parameter an integer and it returns actually an integer in this case. Now, how will I actually implement the method itself? The nice thing is the way of thinking shouldn't change. And that's why what I will do is, I will go down and let's say take the statement that we wrote actually before to calculate the result of, let's say, the factorial of x. Thus, it's the same thing. And now we see actually in the code 3 variables. Okay, we are actually using x as a parameter. This is actually the formal parameter of the function or of the method. We are using r. And last but not least, we are using I. And Java expects now, in this case, a return statement because Java will get confused. It doesn't know exactly what the user wants actually to return in this case. Thus, here we know exactly that the result is stored into a variable with the name r in this case. Okay, last but not least, once we have actually this method, we can actually use it whenever we want. We can use it once, we can use it twice, but we can use it actually more than, let's say, once. Thus, the factorial of x is, and now I will be calling the method factorial with x. Okay, and if the user will enter another number, there is no need, let's say, to replicate actually this code anymore. However, what I will be displaying in this case is factorial of y. Okay, thus you see now the following code. A method which is called factorial. And in the main method, we are calling the factorial twice. Once to calculate the factorial of x, and another time to calculate the factorial of y. Now, once I will compile and run, okay, the algorithm will compile correctly, and we will start actually to get the same, let's say, behavior as before. The program will ask you to enter a number. I will be entering 5. The result will be 120. If I will be entering 4, then actually the factorial of 4 will be 24, and this is actually what will be calculated. Thus, the nice thing here is that the method is implemented once, and once actually we will go and we implement actually the program, okay, we implement the method. If you want actually to use it, you can actually use it. If you want to use it once, you can use it once. If you want to use it twice, you can actually use it twice. And if you don't want actually to use it, you don't need actually to use it at all. Okay, let's go actually to the main method, which is actually the method that the Java virtual machine will expect actually to see in order actually to run. If I have a program in this case without, let's say, a main method, okay, for sure, once I will compile, Java will tell me I don't have any problem. Okay, I see, let's say, a program which is syntactically correct. However, once I run, the Java virtual machine will not look for any method except a main method that is having as a signature public static void. Okay, we will come actually in few minutes actually to the keyword void. Okay, and this method actually expects as a parameter one single parameter, which is an array of strings in this case. It doesn't find it, and in this case, actually what will happen in this case, you get an error which will be thrown in this case. Okay, I will go back and return it. Now, once I will compile and run actually the program will compile correctly, and now the Java virtual machine will see a main method. This is actually the only method that will be executed, and then we will start actually to get, let's say, a dialogue with the user where you just enter now 2 numbers and you get a factorial of the first as well as the second one. Okay, thus the topic of today is just to implement methods and use them whenever you want. And at the end of the day, what we want actually to do is we want actually to take a look at the problem. The problem will be a big one, and then we will decompose it into sub-problems. We will solve actually the sub-problems in terms of methods, and at the end of the day, we will see how actually the program will look nicer. It will be more manageable. It will be more readable, and you will try actually to avoid a lot of problems and mistakes whenever actually you decompose your problem into sub-problems. Now, let's go further. What I want actually to do now is to implement a method which is simpler than actually the factorial method. Now, what we want actually to do is we want to perform the addition of 2 numbers. Okay, thus I will implement a method. The method is static 1. It will return an integer. It takes, let's say, the method is called add. It performs the addition of 2 numbers. And what I will do is I will write, let's say, the 2 parameters x and y, and I have actually to give them actually their, let's say, corresponding data type. And then what I want actually to do is I want actually to return x plus y in this case. Okay, thus it's one way. That means what I will be returning is the result of adding x plus y in this case. Okay, I will go, and what I want actually to do is I want actually to let the user enter two numbers. Thus I will be having two numbers. I can call them x, I can call them y. Okay, and last but not least, what I want actually to do is I want actually to perform, let's say, the result of the addition will be actually printed in this case. Thus I will be printing add of xy in this case. Okay, now once I will compile, Java will see that actually there is a method which is called add. Okay, and that's why it doesn't actually complain. It sees actually that the add is a method that is returning a value. The value is in this case the value is of type integer. That means in this case it can be printed. Now whenever I will run, I will be getting actually the same dialog as we had actually before. However, the main method is not performing the factorial, let's say, calculation of the, or it doesn't actually compute the factorial of the number, but what it performs is the addition of two numbers. That means if I have 5 and I have 9, in this case I know exactly that 5 plus 9 will be equal to 14, and the result actually will be correct. Now, you have to take care, because actually what we are actually doing now is we are expecting that the user will enter an integer. And that's why if someone actually wants to call, let's say, the whole thing with 9.2, okay, Java will throw an exception because actually the input doesn't actually doesn't match the corresponding data type, which is actually an integer data type in this case. Okay, thus the question is it possible to implement a second method, okay, to perform, let's say, the following task? Okay, I will have, let's say, the same signature. However, what I will be having here is, okay, two data types, okay, two variables of data type double in this case. And the body will be the same in this case, which is called x plus y. Okay, now you will see actually like we were doing it actually in lectures, sometimes I will be doing actually mistakes on purpose. Now, you will be seeing actually two methods, both of them are called add. Okay, this concept is called the concept of overloading. Okay, will Java accept it or not? It depends on whether Java will get confused, okay, just by having two methods of the same name in this case. If, let's say, the data types are different, Java will not complain, but if the data types are identical, Java actually will start to complain in this case. However, once I will compile, you will see that actually Java will be having a problem. And the main problem is the following. Here, the problem, if I will click on this one, I'm returning x plus y. Now the data type of x plus y, since actually I'm adding two double actually variables, is of type double. However, what I'm actually telling Java is that actually the data type is an integer. And that's why you have actually two choices. Either you go and you change actually the data type actually to be double, or you have actually to typecast. This is actually one way where Java will accept it. Okay. However, if someone wants actually to keep the result as is, which is of type integer, what I have to do is, as we saw in the first lecture, you take the result of x plus y, and what you have actually to do is you have actually to typecast it into an integer. Now, in this case, Java will not complain. However, the result will be truncated in this case actually into an integer. Thus, let me actually go back and have, let's say, as a return data type double. Okay, thus what I want actually to do is I want, let's say, to call the method in this case with two integers. Okay, now once I will compile and run, Java will not get confused. Why? Because Java sees actually two methods and both of them are called add. However, one of them is expecting two integers as an input and another one is expecting, let's say, two doubles as an input. Thus, once I will enter 9 and 2, Java will know exactly the method that will be called is the first one that is expecting actually two integers in this case. Thus 9 plus 2 will be equal to 11 and the result actually will be correct. Now, if we want actually that the user will be working with doubles, I have actually to change, let's say, the input. Okay, thus the x has to be of type double. And the y could actually be of type integer in this case. Let's see actually whether this one will work or not. And actually before running it, I will ask you, let's say, the following question. Now, I will have 9.2. 9.2 is a double, and that's why this one actually will work perfectly. Now, Java is expecting me to enter actually an integer, and that's why I will be entering 7. And now the question is, if I will perform the addition of 9.2 and 7, Java will have actually two methods. Both of them are called add. It's an overloaded method. However, one of them is expecting two integers and another one is expecting, let's say, two doubles. Now, if I enter 7, Java will convert it automatically into 7.0 without loss of precision. And that's why Java knows exactly the method that will be called is the second one. And in this case, the result will be 16.2. And the method that is called in this case is the second one. Java will not get confused. In this case, if I'm having, let's say, two variables, okay, two methods, both of them are having the same number of parameters, but, okay, the data type of the parameters will be different. Now, let's see this type of overloading, whether actually Java will accept it, yes or no. Okay, thus, once I will compile, Java will have actually a small problem. It tells you, I'm sorry, I'm seeing here, let's say, two methods that takes actually two parameters, and both actually parameters in both methods are of type integer, and that's why I'm confused. If you will tell me add 3, 4, which one will I actually be able to call? You have actually two possibilities. Java will not accept this type of overloading at all. Okay, and that's why what I need actually to do is I need actually to go and change actually this one from, let's say, something which takes as a parameter integers actually to a method that takes as parameters actually something of type double in this case. Okay, thus just keep in mind, if I wouldn't have had, let's say, the second method, the first method, Java will not actually complain at all. Okay, thus if I will go and just actually tell you the user I'm having actually two integers, one of them is let's say x and the other one is y. Okay, and now once I will compile, Java will tell me I really don't have any problem, because in this case, if I want actually to run, okay, I have a method that is expecting actually two doubles. Okay, however, actually what the user will be entering are two integers. The question is, can Java convert an integer to a double without loss of precision? Java will be able to do it. If I have 8, okay, then Java will convert into 8.0. If I have 9, Java will convert to 9.0, and then it performs the addition of 8.0 plus 9.0. The result won't be 17, but it will be 17.0, since actually the return value of the method in this case is a double. Okay, thus, let's go back and let's return, let's say, the addition in this case in order actually to have it. Okay, now, this is now actually the first part where I'm having actually a method which is called addition. The method actually is overloaded, meaning I have actually two methods with the same name. However, actually in this case, the number of parameters is the same in both methods. However, actually the data type of the parameters actually differ from one method to another. Now, what we want actually to do is, we want actually to implement a second method. This second method actually will be a method that doesn't actually return anything, but it performs actually the multiplication of two numbers. And the numbers are, let's say, two integers in this case, int x and int y. Okay, now you see in the signature that I'm not actually returning anything. Why? Because I don't want to return anything. I want actually to print. Okay, now once I will do it, okay, I will be just actually taking system.out.println x times y. Whenever I will compile, Java will be having actually a small problem in this case. It tells you, I'm sorry, the declaration, the signature of the method is not complete. I'm having actually a method. The method is called multiplication. It takes actually two parameters. Both of them are of type integers, but I'm missing actually a return type. Okay, thus Java will tell you, even if the method doesn't return anything, you have actually to write something. And what you have to write if you do not want to return anything is just actually to implement a method which is a void method. Okay, now you have to take care. Now, once we compile, the Java will not have any problem. Okay? Because Java will see, let's say, a signature of a method. The method is a void, and there is no return statement in it. However, you have to take care. If you are having let's say, if you are having a method which is a void method, you are not allowed actually to return anything. If you will do it, Java will tell you, I'm sorry, a void method cannot actually return anything. And this is exactly what you get here as let's say error. That means you will get actually an error. It's an incompatible type, meaning actually I'm not expecting actually to have any return value. However, actually in this case I'm returning something, and that's why Java actually will complain in this case. Now let's try actually to use the method in this case, and what I will do is I will get actually here something like actually a multiplication of xy. Okay, you have to take care. Multiply a method is a method which is a void one. However, actually what I am doing here is, it doesn't actually return anything. What I am actually doing here is, I'm calling the method that doesn't return anything, and I want actually to print, let's say, this void thing. And Java actually will complain, will tell you, I'm sorry, I really cannot do that at all. A void type is not allowed here at all. Why? Because a void method doesn't return anything, and since the method doesn't return anything, you will not be able actually to print it at all. Okay, thus, what I need actually to do is, I need actually to call, let's say, multiply of xy, and once I will do it, you will see exactly how the algorithm actually will behave. It will ask me, let's say, to enter two numbers, okay, integers, 5 and 6. The multiplication will be performed, and since there is a print statement in the method, this is actually the one that will be executed, and the result actually will be 30 in this case. Okay, thus, here you see now, let's say, three different types of method. One method that takes only one parameter. Okay, it's an integer and it turns an integer. You are having two methods. Okay, they are overloaded methods. Both of them are performing the addition, but one of them is performing the addition of two integers and the other one is performing the addition of two, let's say, two floating point numbers. And last but not least, we are having a method. The method is performing the multiplication, and the method is, in this case, a void one. Okay, now let's go actually to implement, let's say, other methods in this case that deal with not only let's say numbers, but actually sometimes I want actually to perform, let's say, the reverse of a string. The question is, how can I do it? I will implement a method. The method will return a string. It's called reverse. It takes a string as input in this case. And now the way of thinking actually should be the same. Okay, thus the signature of the method is the following. The method is called reverse. It takes as an input a string and it returns a string. And that's why what I want actually to do is, I want actually to take, let's say, R, which is actually the result. The result in the beginning is an empty one. And then I will be having a for loop that starts from index 0, which corresponds to the first character of the string. It goes and it stops whenever actually I reach, in this case, the length. Okay, and last but not least, if I haven't reached it, then I have actually to go to the next one. And what I have actually to do is, I have actually to take the R and then concatenate actually the characters one by one. Okay, that's the question is, where do I have actually to concatenate forwards or backwards? Okay, we can actually try it out just by taking the char at of I. Okay, and what I will do is, I will just actually concatenate it to the existing result. And last but not least, I will return LR in this case. Now, this is now a method. The method is something actually that returns a string. If you do not actually return anything, Java will complain. Will tell you, I'm sorry, I'm having a problem. There is a method. Okay, the data type of the output is a string, but the method is missing a return statement. Once I will return it back, you get actually now, let's say, something that compiles correctly. Why? Because actually the method reverse is returning a string and R is of type actually string in this case. Now, the question is, how can we, let's say, test it? Okay, I will enter actually text. Now, in this case, I will do it with next line. And last but not least, the X will be, in this case, of type string. And then what I will do is, I will go and print, in this case, the reverse of the string. Okay, if you do not actually print it, the task actually will be performed. Meaning here, in this case, if I will write reverse of X, okay, in this case, what will happen in this case, once I will compile, Java will ask the user actually to input text. Okay, I will be inputting text. Okay, hello world. Okay, and what will happen in this case, Java actually will perform the reverse, but since actually I'm not doing anything with the output that was actually returned by the method, nothing actually will be displayed, and that's why now if I want to see the result, I will write system.out.println reverse of x, okay, and last but not least, once I will compile and run, you get actually now the following actually behavior. If I have, let's say, a string which is hello world, you will see exactly what will happen. The hello world will be reversed in this case, meaning actually the method is working actually correctly. What I'm doing here is I'm taking the characters one by one, I'm concatenating them at the front of the result string in this case. Okay, thus the reverse is done. Now we want actually to implement a second method. Okay, this method actually should check whether a character is contained in a string, yes or no. Thus, it's a method which should return either true or false. That means the return value is a Boolean one. The method is called contains, and it takes actually two parameters. The first parameter is a character C, okay, and the second parameter is a string S. And what this method actually should do is it should check whether the character exists in the string, the character C exists in the string, yes or no. Okay, now without using any predefined method, what we want actually to do is we want actually to just actually go from I equal to 0 till I less than s dot length, and every time I will just increment actually the I by 1. Now the question is, when should I stop? Okay, whenever I know that the C is equal to s dot char at of I know exactly that I have actually found it. That means what I have to return in this case is a true. Now, if I will compile, Java will complain, will tell me, okay, I'm having actually a small problem. I don't see a return statement in this case. Now, everyone actually will see that there is one return statement inside actually the for loop. But actually this return statement could happen that actually it will never be returned if the character does not exist. And that's why the question is, what should I do? I should actually think about, let's say, the case when actually the method should return false. And the method actually should return false if the following will happen. I will compare C with s.char at of 0. And I don't actually find the character in the first position. And if the string is containing more than one character, okay, what this loop will do is we'll go increment the I by 1, meaning I is equal to 1. I will go to the second character and I will check whether this character is equal actually to the C, yes or no. If it is not the case, I will not return true. Now the question is, when should I return false? I should return false whenever actually I traverse the whole string, meaning I reach actually the s dot length. Thus, I know exactly at the end of the day what I need to do is, okay, outside actually the loop, I will be returning false. And the meaning of it is, whenever I encounter a character in a string, I have to stop. The return actually statement will abort from the execution of the method and will return true. However, if I will be just checking the characters one by one till I reach actually the last character and I don't find it, then in this case I will be returning false. Now the question is, let's try actually to test it. I will just ask the user to enter a string. Okay, this is my x. Okay, and I will ask the user to enter, in this case, another, let's say, string. Okay, a character. Please enter a character. Okay, and the user will enter, in this case, the character C. The question is, how can I make sure that the user will be entering a character? I will be using sc.nextLine. Okay, however, in this case, Java will complain a little bit because the next line will be having actually a string. Now, actually, what I want to do is I want to check whether, let's say, the x is containing C and x in this case. If I will keep it like that, Java will be having a problem. And the problem actually lies in the line where the character C is equal to sc dot next line. The question is, the next line, okay, is something that will let's say, expect the user actually to enter a string, but a string cannot be put into a character. And that's why what I have actually to do is, I have actually to convert this string into the character just actually by getting the first character from it. Thus, I will write char at of 0. Okay, and now, once I will compile, Java actually will see exactly, let's say, the following, that the user in the C will be entering actually first a string. This string actually you will get the first character of it, and this character can be stored into a variable C of type character in this case. Now, let's try it out. I will have, let's say, something of the following form. Okay, the string is hello world. Okay, and let's say, string is R. Okay, the character is R. Now, once actually I have it, the method should return true, and you get actually true as a result. Now, if I will compile actually this one and run it with hello world and Z, you will see exactly what will happen. Hello world is a string. However, actually the Z is not contained in the hello world. That's what will happen in this case. Java actually will traverse actually the whole string. Whenever actually my eye reaches the length of the string, it doesn't actually find it. It stops just actually by returning false in this case. Okay, nice. This is now actually the first method. Okay, the second method that we want actually to do is a method that will check whether that will convert, let's say, uh, let's that will calculate the total number of occurrences of a character in a string. Okay, thus what I will do is I will take actually the same method, and I will replicate it, and I will call the method number of occurrences. Okay, thus in this case I will be having something that returns an integer. Okay, and what I will do is I will have a variable called R, okay, or C, R. R is equal to 0 in the beginning, meaning I haven't actually started to count the total number of occurrences in this case. And what I will do is, every time I will find it, I will increment actually the R by 1. And last but not least, I will just actually return the R in this case. Okay, thus the method here is similar actually to the method which checks whether a character occurs in a string that returns actually a Boolean value. Now what I want actually to do is I want actually to calculate the total number of occurrences of specific character in a string. Okay, thus once we go actually further, what we want actually to do is we do not want actually to call the contains, but we want actually to call the number of occurrences of, let's say, the character in the string. The method is called numoccur. Okay, and now once I will compile, Java will tell me, okay, you are having two methods, or different actually methods. One of them is called actually contains, that takes two parameters. The other one is called numoccur. It takes actually two parameters. Both of them are of the same type. There is actually no overloading in this case, and that's why Java knows exactly the numoccur method is the one that will be called. Thus, once I will compile it and run it, if I have, let's say, a string which is hello world, and I want to calculate the total number of occurrences of L in hello world, I know exactly that actually I should get 3 as a result, and the result actually will be correct. Now, if you run actually this one with hello world and that, in this case, I know exactly that there is no occurrence of that in hello world, and then what you get actually as a result is 0. Okay, nice. It's good. I'm having now a method called number of occurrence. Okay, and this method, let's say, calculates the total number of occurrences of every character, of a character C in a string S. Now, what I want actually to do now is to implement a second method. The method will return a string. It expects as an input a string 2. And what this method actually should do is it should calculate the total number of occurrences of every character in a string. And the result string should consist of every character followed by its number of occurrences. Meaning if I have something of the form ABC, the result, if I have something of the form ABC, the result should be A1, B1, C1. If I have something of the form A, B, C, A, then in this case, what I need actually to get as a result is something of the form A, total number of occurrences is 3, B, the total number of occurrences is 2, A, the total number of occurrences is 3, B, the total number of occurrences is 2, C is the total number of occurrences is 1, and A is the total number of occurrences is 3. This is exactly what I want actually to implement. A method that takes as input a string and it encodes, let's say, the total number of occurrences of every character in the string itself. And that's why the result will be always the character followed by the total number of occurrences in the whole string. Now the question is, how can I implement this method? Okay. Thus, it's a method that takes as an input a string and returns string, meaning before actually doing anything, I know exactly that the result in this case will be an empty one. Then I will be having actually a for loop, okay, that takes the characters one by one actually from the string. That means I will start with int I equal to 0, I less than s dot length, and last but not least, I plus plus. Okay, now what I want actually to do now is for every character, I want actually to calculate the total number of occurrences of this character in the string. And the nice thing is we have a method that does that. The method is called numoccur, okay, that takes in this case the character, okay, s dot char add of I and calculates the total number of occurrences of it in s. Once I have that, my result now should have the following. I have actually the result, and I have to concatenate to it, okay, R plus, in this case, the S dot char add of I, and last but not least, plus the total number of occurrences which is stored in C. Once I'm done actually with that, I will be returning, let's say, the R as a result. Thus, it's a method, it's called encode. What it does is the following. In the beginning, the string is empty. And then what I have to do is, I have actually to take this string and traverse the character one by one. Okay, this is what the method does. And for every I will just calculate the total number of occurrences of the character in position I in the string. And once I have it, I just concatenate it actually to the old result in this case. Now, let me try actually to test it. Okay, thus I will be expecting only one input. The method is called encode. It takes only one parameter. Okay, and I will be encoding x in this case. Okay, thus once I will compile and run it, okay, then I will be having as a result, if I run it with ABC, I should expect as a result A1, B1, C1. And this one actually works nicely. Now, once I will do it with, let's say, something of type A, B, C, A, B, B, A, then in this case, and C, then in this case, I know exactly that the A occurs 3 times. The B occurs 3 times, the C occurs twice, A is repeated because actually my encoding actually goes through the string character by character and it doesn't actually, let's say, check whether the character occurs in the string, yes or no. And what you see here, you see that actually that the encoding is done actually correctly in this case. Okay, now the question is, what would have happened if I will be using actually the shorthand, in this case, R plus equal to S dot char add of I plus C. Now, once you will compile, Java will not have any problem actually at compile time. However, once I will run it, if I will run it with the string ABC, I should expect A1, B1, C1, but what you get here is you get actually an integer. Why? Because R plus equal to S dot char add of I plus C, as actually we saw in the first lecture, corresponds to R plus and then this one actually between brackets. And you have actually to take care. First lecture, as I told you before, is the most important lecture because it tells you exactly if I will be having actually the addition of s dot char at of I plus c. S dot char at of I is of type character, the c is of type integer. Characters and integers are compatible data types. That means the result will be, let's say, to get actually the integer and add it to the Unicode of the character in this case. And last but not least, at the end, everything actually will be converted into a string that will be actually returned. However, actually this one corresponds actually to, let's say, adding integers with the Unicode of characters in this case. And that's why I know exactly in this case the way how the concatenation is done. Shouldn't be actually, let's say, done just by adding an integer to a character. Now, if I will remove it, what will happen in this case? R is equal to R plus s dot char at of I plus c will have actually an addition of a string with the character. This one actually will be converted into a string, and then this string actually will be added into an integer. The whole thing actually will be concatenated because actually Java will typecast actually this integer into a string and concatenate actually this one. And that's why once I will do it, let's say this way, okay, the input will be correct. If I will do it with A, B, C, A, then the A occurs twice, the B occurs once, the C occurs once, and the A occurs twice. Now the question is, what should I do if I want actually to use the shorthand? Okay, it's an easy task. What you have to do is you have actually to force Java to perform actually an addition of an integer or a character with a string, and that's why what you need to do is just in order to avoid the addition of a character with an integer, you add actually a string between them. Thus, in this case, once you will compile and you will run, you will be getting actually the correct result. That means if I will run it with hello world, okay, what you will get actually as a result is H occurs once, E occurs once, L occurs thrice, L occurs thrice, the O occurs twice, and then actually you see that the space, okay, occurs once because actually you are having between the hello and the word a space actually in this case. Now, the question is, I would love actually to change the method slightly in order that I will not, let's say, have as a result, meaning if I have, let's say, A, B, C, A, then actually my result should be in this case A1, I'm sorry, A2, B1, and C1. This is it, meaning I want actually to change the code in such a way that whenever I have, let's say, A, B, B, A, okay, then actually this one should be, let's say, converted into A2. However, the second A shouldn't be calculated anymore, okay, and then I will be having B2, and that's it. Okay, the question is, what should I do? Okay, now, one way actually to solve it is just actually to know exactly that whenever I store in the result a character, okay, then this character shouldn't be handled anymore. And that's why what I have actually to do is I have to add an if statement in this case that says the following. I will do actually this task only if, and then I have a method which is called contains. Okay, that's the method is already defined in this case. If, let's say, my character, which is s.char at of I, is not contained in the string R, I will actually perform the task. However, once the s.char at of I is inside actually the character, in this case, I will know exactly that I don't want actually to perform in the result. I don't want actually to perform it anymore. Okay, thus I will add now, let's say, the then part, and the then part will be, meaning actually this one will only be executed if the character hasn't been actually handled before in the R in this case. Now, the nice thing is, once you will compile and you will run, you will be getting a nice result. If I have A, B, C, no change, you will be having A1, B1, C1. However, once you are having, let's say, a kind of duplicates in the string A, B, B, C, A, B, A, then in this case you will see that A will occur only once. However, total number of occurrences of the A in the string, in the original string, is 4 times. B occurs only once in the result. However, actually the total number of occurrences of the B is 3, and the C occurs only once in this case. Okay, and the total number of occurrences is 1. Okay, last part is about how Java will pass actually parameters to methods. I will just implement a simple method. Okay, it's a static method. It returns an integer, and this one is having as an input int x. Okay, that's what I want to do is I want to increment the x by 1, and last but not least return the x in this case. Okay, thus what I want actually to do is I want actually to test it. I will let the user enter a number, and this one is next int. And then what I want actually to do is I want, let's say, I will call it A. Okay, this is actually the parameter. And before actually doing that, I want actually to take a look at, let's say, the value of the A in this case. And that's why the value of A before, meaning before actually the execution of F, is, and now I will just concatenate actually to it A. And then what I want actually to do is I want actually to call it f of A. Okay, and last but not least, I want actually to take a look at the whole statement after. Okay, thus we'll add a semicolon here. I will add a semicolon, and this one is after the execution. Okay, now let's take a look at the method again. The method actually takes one input. The input is of type integer, and it returns actually an integer in this case. Okay, and what it does is it performs actually, let's say, the increment, it increments actually the value of x by 1, and then actually it returns it. And then what I'm doing here is in the main method, I'm having, let's say, A. This is my actual parameter that I want actually to pass to the method f. And the question is, I want actually to see the value of A before the execution of the method f, as well as the value of A after the execution of f. Now, let's actually do it. Once I will compile, okay, I'm being a semicolon missing. Once I will compile, this one hopefully will now compile actually correctly. Once I will run, you will be getting the following. Okay, I will be entering a value, a number which is actually 6. Now what I want actually to do is I want actually to see the value before and after. Now everyone, okay, would actually think that the value of A after is 7, because actually the method is incrementing the x by 1. However, you see that the value of A doesn't actually change in this case. Okay, thus in computer science and in computer programming, there are actually two different types of how parameters are passed actually to methods. Okay, thus in Java, if I'm dealing actually with primitive data types, the passing of parameters will be done by value. Meaning I will not be working on the original, let's say, value of A, okay, but I'm working actually on a copy of A. Okay, thus if I'm working on a copy of A, the original won't change. Okay, thus the passing of parameters in Java is done by value rather than by reference. There are programming languages where in this case you do not work on a copy, but you work actually on, let's say, the memory address of the variable itself, meaning you are working actually on the reference in this case. However, actually Java, since you are dealing with primitive data types, the passing of parameters will be done actually by value, and that's why this one actually won't change. Now, we will see here the effect of the method itself. Okay, the effect of the method will be a clear one. That means actually the f should be, in this case, f of a should give me, actually in this case, if I will be working with 10 as a value, okay, that's, you have actually to take care. I want actually to know the value of a before, the value of a after. However, in between, I want actually to see the effect of the f of a in this case. And you see that the f of a will be incrementing actually the copy of, let's say, the variable a to be equal to 11. And once actually you will, let's say, display it, you will get actually 11 as a result. But the a itself doesn't actually change its value. And that's why if anyone want actually to do the swap of two variables in this way, okay, you have actually to take care. If you are having two variables, x and y, and you want actually to swap them, okay, that's what you can do is, you can actually use a temporary variable, tmp, okay, and you store in it x. And then you can take an x and change actually the value to be equal to y. And the y is equal to tmp. Okay, thus, if I want actually to do that, if I will enter actually a number, the number is a, okay, I can call it x, okay, it doesn't matter because actually the scope of this x is, let's say, the scope of the main method. The scope of this x is the scope of this actually method. The scope of, let's say, if I am having another x, if you see it here, is the scope of it is just actually the body of the method in this case. And that's why the x that I'm having here is different than the x that I'm having, let's say, in the other method. Thus, let me actually do it with x, and I will write the value of x before the swap is, this is my x. I will just enter another number, which is the y, int y. Value of y before the swap is y. And then what I want actually to do is, I want actually to perform the swap of x and y. Okay. And last but not least, what I want actually to do is, I want to just actually to look at the values of x and y after the swap. Okay, that's, I will get, let's say, this statement. And then what you will have actually to do is, you have actually to have the value of x after the swap is, and then actually the same, I will do it actually with the y. The y after the swap is y in this case. Okay, now let's see. Once I will compile, okay, this one will not compile. Okay, y is equal to tmp, it's tmp. Now once I will compile, this one will compile correctly, and let's see actually the result in this case. If I am having actually two variables, x and y, okay, I will enter the first number to be equal to 5. The value of x before the swap is 5. The value of y after the swap is 10. Okay, and then you see that the value of x before the swap is 5. The value of y before the swap is 10, and the value of x remains actually after the swap 5, and the value of y before after the swap, I will just actually replace it, after the swap will be 5. Okay, thus, in order to see that in a nicer way, I will get here, please enter another number, please enter another number, and I get actually the y here, just actually to see the two things done, let's say, in this case with x and y. Okay, thus, let's try it actually again. And now we will be entering actually two numbers. Please enter the first number. The first number is 5. The second number is 7. Thus, the value of x before the swap is 5, and the value of y before the swap is 7. And then after the swap, the value of x remains actually 5, and the value of y remains 7. Why? Because the passing of parameters is done by value, meaning I'm taking actually a copy of the variables rather than actually the reference in this case. Okay, thus, what we want actually to take home from this lecture is that having actually the possibility to implement methods will give you, let's say, a way to decompose a problem into sub-problems, and that's why you see that the encode method, okay, looks here actually really easy because we are having methods that we are, let's say, using. Here you see actually one for loop that I am using. However, in the contains, there is another for loop. In the number of occurrence, there is another loop. And that's why if you want actually to implement that without using actually methods, the program will become a little bit monolithic in terms of spaghetti code. You will see a lot of loops inside each other. Thus, it's not easy to manage if there is actually a bug. However, once you decompose the problem into sub-problems, the idea, let's say, will be, the program actually will be more readable, it's more maintainable, and it's easy, let's say, to change. And if you want actually to use methods, let's say, in other methods actually to solve another problem, this can be done too. Okay, the second message is that once you want actually to know how the parameters are passed to a method, since actually I'm dealing with primitive data types, and the primitive data types are integers, floating point, characters, as well as Boolean, the Boolean data type. Okay, in this case, the passing of parameters is done by value. Thus, I won't actually work on the original variable, but I'm working actually on a copy of it. And that's why if you want actually to do the swap, okay, the swap actually will not change actually the values, of the original values of x and y in this case. Thank you very much. Okay, and have a nice day.